everyone. I'd like to start off by getting a quick count. Raise your hand if you went to Sandy's talk. All right, very cool. So this one is kind of related to give a, I mostly agree with everything she said. And I would like to say too, if you walk out of this talk disagreeing with everything that I say here, please, for the love of God, follow what she said. So, wanted to start out with something very delicious, black claw. And the talk is Delicious Controversy. I'm going to talk about documentation and tests. So why am I giving this talk? It is actually kind of scary to get up in front of the best and brightest and give a talk that you think is going to be pretty controversial. But I'm doing it because Code School is a pretty interesting project, and we've learned a lot doing it. We've got over 27,000 lines of code, including specs, 29 committers, and lots of rotation. You know, NB Labs also does client work, so we have people coming onto Code School and moving back off onto client work, sometimes once or twice a month. And there's a lot of lessons learned from doing that, because when we started Code School, we drank a lot of the Kool-Aid. You know, test-driven development is the golden path to good tests and good design. Code can be self-documenting, things like that. And we've learned that not all of that Kool-Aid is necessarily practical. So I'd like to spend the next 30 minutes or so being kind of a champion of practicality and see where that takes us. So I want to start off with talking about docs. And documentation kind of has a bad rap. Personally, one of the last classes I took in college was software engineering. And in that class, they asked me to write a spec doc for a vending machine. And that spec doc ended up being well in excess of 30 pages. We had 2 people working on it, and that was not nearly as long as the teacher wanted, which was pretty ridiculous. But spec docs are one extreme, and self-documenting code is the other extreme. So this is kind of the premise of self-documenting code. You have a class called subscription, you have a method.cancel. You write your code in a concise and clear manner. People reading the code can understand it, and then you don't need to write documentation, right? Because it's obvious what cancel does on a subscription. It cancels the subscription, right? Well, that might not tell you a few things, like maybe it sends an email to the client telling them that their subscription's been canceled. Or maybe it refunds them for their partial month. Or maybe it deletes all of their data permanently. Does this happen in a job? Does it not happen in a job? Cancel doesn't tell you these things. So then the first thing we programmers do is add a bang to it. This is a dangerous method. Oh, yeah, that doesn't really tell me anything. Does that mean it's going to throw an exception or that it's going to wipe the server? I'm not really sure. So self-documenting code is a total pipe dream, and that is not necessarily intuitive. Because when you're writing code, you have the benefit of all the context when you were writing that. And you come back, you look at it 6 months later, your brain does this amazing job of pulling in the context as you're reading the code again, right? Plus, you're reading your own code. It's written in your style, something you understand. When one of your peers comes and looks at your code, that's just not true. They have to search around, get the same context that you had, especially if they've never worked on the project before, and especially if it's something as complex as subscriptions. It's kind of like a puzzle piece. Every method you write has a well-defined API like a puzzle piece. You can kind of tell that this puzzle piece is probably a leaf or something like that. It's very easy to understand by looking at it for just a few seconds. But when you go into an application like Code School, it's like being thrown into a sea of puzzle pieces and being asked to figure it out without the benefit of a picture of what that puzzle is going to look like. And you can do that. You can start from the corner and figure out each puzzle piece individually and piece it all together. So it can be done, but it takes way too damn long, especially if we have people who we want to have work on code school for just a couple weeks and then move back off onto a client project. They'll spend the next week figuring out what it is they need to do. It's also really soul-crushing, right? Everybody at NV Labs has a very healthy respect for each other, you know, and when I read code written by one of my peers and I respect them and I can't figure it out, that makes me feel stupid. It doesn't matter how long, you know, I've been programming for 10 years, but, you know, it doesn't necessarily matter. So then the next part is when people say, all right, in addition to self-documenting code, we're going to use specs, right? We're going to use Cucumber. These things are our documentation. They tell us what our features are. And I would like everyone to imagine for a moment if the Rails core team deleted all of their API docs and told you to go look at the specs. It doesn't work that way. Tests are terrible documentation. It's not the right mindset. When you're writing the features, that's something that it does from the user perspective. It doesn't tell you what you need to do in order to use the class. Plus, we're basically telling people in order to understand 11,000 lines of code, please go read 16,000 lines of RSpec. You know, you're putting your peers on a rack and you are stretching them to their limit on the very first day. It doesn't work. So documents exist so others can use classes without understanding them. You know, it would be impossible for any of us to get very far in using Rails or even Sinatra necessarily if we had to deeply understand how the entire system worked. We don't have enough hours in the day to do that. So, how do you make sane and useful docs? It's really not that hard. You want to document all of your public methods. You want to document as you go. It's really important to document as you go. You're going to have a lot of pain writing documents up front if you don't have any in your code base right now. I sat down and documented an 800-line class, and it took me the better part of a day. Because when you document something and you haven't written it, you don't have to look at just that 800-line class. You also have to look at all of the other classes it uses. You want to keep it very short, and you never want to discuss implementation. As soon as you discuss implementation, you've created a maintenance, right? You want to, you know, sort. It sorts. It doesn't implement bubble sort. It doesn't implement quick sort. It just sorts. And you want to answer 3 questions. What does the method need? And that goes beyond just parameters. That also goes to the state of the class, right? Maybe you should only really call subscription.cancel if the subscription isn't already canceled. What does the method do? Which is the obvious part. It cancels the subscription. And you need to say, what are the far-reaching consequences? It emails the user. It immediately refunds their money. It creates a job that refunds their money at some later point. These are the things that people need to know so that they can use the subscription class without emailing 10,000 customers or deleting all of the data in the database or something like that. In short, you need to treat every single thing you write like a public API, right? There's a lot of amazing docs for a lot of the open source projects that we use out there, but in our internal applications, we usually do a very poor job of emulating those docs. And generally, I think that should change. Ideally, you're going to write your docs so that you could put it up on GitHub, and other people who have never seen your code can use it without understanding it, because it makes all of your peers around you much faster. You're lifting up the entire team by doing this, right? Because maybe somebody needs to implement something really quick using subscription, and instead of having to spend all day figuring out what exactly is going to happen in subscription, they can let go of that fear because you've documented it, and they know that calling cancel isn't going to destroy the user's data or something like that. You want to give them the puzzle. You want to give them a picture of the puzzle so that when they start putting the pieces together, they know if they're on the right track. So the next spot is testing. Oh, testing. Testing is a minefield of opinions. It is always a very interesting subject. We have 16,000 lines of specs. That's 5,000 more lines in application code. And I feel like the testing culture is such that I could get up on stage and feel proud about that, right? I've written a 500-line application, I have 1,000,000 lines of specs, and I'd get a standing ovation because 2,000% code coverage is a good thing, right? Well, we found that that's 16,000 lines of maintenance, you know? Just because they're tests doesn't mean that they come for free. So why do we write tests in the first place? There's really only one reason that we write tests, and it's to prevent bugs. You want to know 6 months from now if the feature you write today is still working. That's it. There's no other reason that you have tests in your application. If you have them there for another reason, please get rid of them. So I want to talk about two broad categories of tests here. One is unit tests, and the other is integration tests. Unit tests, defined very broadly, are tests. They test a method without leaving the class, right? So if you are testing something on subscription, you would probably mock out user. And I have a very strong opinion about unit tests. They are bad tests, just categorically bad tests. There's way too many lines of test code per line covered in your application, right? If you have a 1 or 2 line method, when you write a unit test, you're going to instantiate it, you're going to mock something out, you're going to run that method, you are going to assert something, and maybe 2 things, right? Now, 5 lines for 1 or 2 line method. You toss that out over an 11,000 line application, and you're in trouble. It gets really ridiculous really fast. They're too coupled to the implementation, precisely because you're mocking things out. Now, especially if you've made the mistake of stubbing internal methods, like Sandy was talking about earlier today, then you're really in trouble. That's a horrible, horrible test, and I have a suggestion for that later. They create too much maintenance, and they fail to ensure that you're using a class correctly. And this goes beyond just making sure that you are treating the API of the class correctly. You know, it's also that perhaps you're changing some internal state on the class that you're using. And that internal state, when you call another method on it later, breaks. Right? These are the kind of things that only an integration test can capture. You know, it's sometimes you will hear the argument that you want to mock out things like queries because you don't want to test PostgreSQL, but that's not the point. You're not testing PostgreSQL, you're testing that you're using it correctly. These are all very complex systems. Even your classes are complex in their own way. So now I get to have a rant. I'm going to have a little fun. So if unit tests are bad tests, what follows? If unit tests are bad tests, that means test-driven development creates bad tests. And that's okay. Test-driven development is about good design, not good tests. The reason you use test-driven development is it forces you to use your code as you're writing it to make sure that you like your own API as you're developing it, which is useful. And you can tell how useful it is by how passionate people get about test-driven development. I remember reading a blog post while I was writing this talk that, and I'm paraphrasing, said, if you don't practice test-driven development on a day-to-day basis, you should reconsider your career as a programmer. And that is utter bullshit. I mean, can you imagine? Linus Torvalds would not be a programmer if that were true. He did not create Linux with test-driven development. Plus, test-driven development does not guarantee good design. And we need to stop acting like it does. I shed a tear every time I see a job posting that says, we practice TDD all the time and you need to be an uber master at TDD in order to get this job. Because there are plenty of people that like test-driven development, and that's great, but you're also ensuring that you don't have a diverse kind of programmer at your office. And eventually that may hurt you. Maybe it won't, maybe it will. We've kind of gotten to the point for some people where we're worshiping our hammer, and we are burning people at the stake because they do not practice TDD. I'm personally just kind of tired of meeting really great developers that are carrying around a lot of guilt over the fact that they don't practice test-driven development. I don't. I tried it. It didn't work for me. I've been very successful without it. I write code faster, better without it. I know it because I tried it, and I did it the right way, how everybody has told me to do it. And if there's anybody here that doesn't do TDD, if you've tried it and it didn't work for you, that's fine. So use it if it works for you. It's great. But please delete your unit tests after you replace them with integration tests. An integration test tests the full stack, and they check the result. Integration tests are never concerned with implementation. And they are beautiful. I love them. My favorite tests I've ever seen are in Code School. When we create a course, like, for example, jQuery, or try jQuery, we have an API that allows us to send correct and incorrect answers through. We have a very complete set of specs that send good answers, bad answers, answers that try to hack the server, answers that try to crash the server, through. And we don't mock out the executor. The executor is a whole other app, completely separate. For jQuery, in fact, our executor is in Node, and our application's in Rails. And we allow those requests to pass through to an executor that runs locally. So now we're testing two apps, one set of tests. Do our executors have some tests? Yes, they do. But the most important tests are the tests that we have in the course. And it's an amazingly efficient use of our time and resources because the tests are very easy to write too. It's testing our complex interactions, and we're in the right mindset. We're thinking about, does this feature work? Which is what we really care about at the end of the day. If somebody creates an account, is that account created? Can they add a course to their account? Can they play the course? These are the things we care about, not whether or not something calls another method. So, if you're in the Rails community, the first thing that comes to mind is Capybara, right? Because Capybara is the be-all to end-all of integration testing. You're going in through HTML, you test literally the full stack, and you're checking everything back in HTML. You're seeing it as a user would see it. No. No, 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 no. Capybara takes way too long to implement. It's an amazing piece of software. I have a lot of respect for the people that wrote it, and I don't think you should not use it ever. But if you have all of your tests in Capybara, all of your integration tests in Capybara, you're setting yourself up for major, major pain. There's way too much maintenance. There's too many gotchas. It doesn't encourage good code. If codeschool.com were written, God forbid, all 11,000 lines inside of the controllers, Capybara would test that just fine, and it wouldn't care. And even worse, view changes tend to break tests. We have this problem with our designers where they change something in the view, and because we were a little too eager in our scoping, all of a sudden our integration tests fail. Travis CI screams at everybody and nobody's happy. So what? I mean, if you're not going to use Capybara, what are you going to do? So I would like to suggest sane tests by testing your models, by using services, and by using presenters. So a model. Actually, let me go back for a second. In order to get sane tests, you have to architect your application in a certain way, right? If you have all of your code shoved into a controller, that's difficult to test. I am generally not a fan, actually, of changing my code to make it easier to test unless if it's also obviously just architected poorly. I'm okay with this personally because it really feels like the right way to do it, and you get a lot of other benefits by writing Rails apps this way. So a model, we're all pretty familiar with it. It's your core application logic. It does one thing, and it does it well. You know, your subscription should not be handling directly credit cards. Your users should not be handling subscriptions. Your courses should not be handling challenges. It's one thing and one thing only. And they're not necessarily active record. I think the community's mostly moved beyond that, but it's worth saying. So let's take a few examples. Consider a subscription model that has a method called charge, and all it does is grab a billing subscription, call charge on it. If it works, set paid to true and increment the next bill on date. This is pretty easy to read, but it still doesn't tell you a lot. Does charge happen immediately? What exactly does that paid thing mean? Does that stay true? Does that turn false the next day? What is this billing subscription thing? I'm going to have to go read billing subscription now to find out, is that a remote call, a local call, what? Well, instead, document it. I tend to prefer Yard. It makes things really easy to document, but it really does not matter what you use. TomDoc, RDoc, Yard, nothing, it doesn't matter, as long as you have some text above your classes and methods. This tells us a lot. Now we know paid is true if payment is current, so they're paid up. Okay, that answers that question. It immediately attempts to charge. That's pretty important. And it also, we know that it updates next bill on. Now we don't even need to read that code. We just read the docs. We also know, as a bonus, that it returns the date that the next charge should be attempted, and that it throws an error if billing happens to be down. No idea that that was going to happen without some documentation. Plus, we're making billing object private. So who cares what it does or how it does it? Unless if you are changing subscription, you don't need to care, because the documents are telling you everything that you need to know. So how do you test something like that? I tend to like VCR. You could also use mocks. This is one case where mocks are great because you don't want to be talking to credit card companies when you run your tests. But it's very easy. You create a subscription, you charge it, you assert that it's been paid, and you assert that the next bill on date is what you expect it to be. Done. You've tested that method. And if you're using VCR like this, you've also indirectly ensured that it's using subscription billing or billing subscription correctly. Because VCR is going to pretend with a request response cycle, and it'll return all the data you need. So services. Services orchestrate models. They handle logic that doesn't fit into a model, and they help your controllers become paper thin, which is really important. So imagine we have a controller with a create action. We're creating a new subscription on it, and we want to see if that subscription gets a discount, or maybe everything gets a discount. It's not that bad, but controllers have enough to do. Controllers are handling your filters. They're probably handling your security. They are handling parameters. There's enough going on there. They don't need to know about your business logic too. Plus, what if I wanted to be able to create subscriptions through a CSV file and run a rig task? I can't do it like this, or I'd have to duplicate code, right? So instead, create a service and make your controller just ridiculously simple. We create the subscription service, we ask it to create, it redirects and renders. Now the controller is handling the bare minimum of what it possibly can handle. what does the service look like when you document it? And what does the implementation look like? Well, again, it tells us that we're creating a new service, we're applying a discount if it's appropriate, and we're, again, saying it immediately charges, carrying that documentation up, carrying up the errors. And when you test a service, it is equally easy. You create the service, you pass in some good parameters, you assert that the service created successfully, and you assert that the subscription was paid. Now, normally, if you were doing a unit test, you would never, ever, ever do service.subscription.paid. But this is an integration test. We want to test the result of the operation. We want to make sure that the subscription is marked paid. If that means you have to do a database query inside of your integration test, that's fine. That's what they're there for. And we're also making sure that the discount was applied. And presenters. They've been around for a little while, and I'm seeing them used a lot more, which is great. They help display complex views. They're template and framework agnostic, ideally. If you have to bend on that a little bit, that's okay, but ideally, your presenters don't necessarily know about HTML. And they help controllers and views become paper thin, which is, again, really important. So before you have a presenter, you get something like this, where the logic that you've got in your view is not that bad, right? This is pretty easy stuff. Again, take that, compound it across 11,000 lines of code, it's bad. It doesn't work. Because now you really kind of need to test that with something like Capybara. So instead, use a presenter. There's really nothing to test there. I mean, the bug that you could have would be misspelling a method name. If you really feel like you need to test to make sure that you're not misspelling method names, that's fine, but personally, I don't think that that's a useful test. You don't get a lot of value out of the lines that you have to write and maintain when you write a test like that. And then presenters themselves are really easy to write. It's very quick to write presenters usually. And again, you know, documentation does not take that long. It's one line. And you don't have to debug documentation, which is kind of nice. Finally, testing a presenter. You create one, and you just assert. And technically, we actually use RSpec in all of our stuff, but these make for shorter examples. So what about controllers and views? They should be so simple that testing them is a complete waste of your time. Controllers and views are configuration. We've already got plenty of templating languages out there that do not allow logic inside of the template because it's just generally not a good idea to allow that. Controllers are just barely complex enough right now that you cannot express them in YAML. But you almost could, and that's how every controller you write should be. Because if you're using services and presenters instead, and you decide, hey, I would like to write a Ruby motion app, then you've got something to start with. You can use those services and presenters inside of something like a Ruby motion app or a command line application. Maybe you don't, but it doesn't matter. It still makes your test much easier because you're not having to deal with HTML. Even if you have to pull parameter processing and redirects into a service. I am next week going to be writing a service that handles flash notifications because they were just complex enough that I didn't feel like they belonged to the controller anymore. Whatever it takes so that you can keep your application fast to write, easy to understand, and easy to test. We don't want skinny controllers, we want skeletal controllers. We want just a bag of bones walking around. That's it. So, some guidelines. These are just guidelines. They're not religion. Every class should be treated as an API defined by its public methods. A method should only be public if it absolutely must be. There is a lot of cost to having a public method if you're doing anything like this, because you have to document it and you need to write an integration test on it. You need to document your public methods, write feature and integration tests for them. And you need to remember, as you're writing your tests and as you're writing your application, that every single line of code you write has a maintenance cost, even if it's tests. In a perfect world, you would have fewer lines of our spec code than application code. I'm not sure that's possible. I would like to try it one day. I would like to shoot for that. But it's hard to get there when you're starting from 16,000 lines. You want to refactor slowly. The big refactor is the cousin of the big rewrite. We are taking it very slowly. We still have plenty of capybara tests, and we still will by the end of the year, I'm sure. But we are taking things out of our controllers, creating services, and testing those services. After we get 2 sets of integration tests passing, delete the capybara tests. And like I said, these are guidelines. Spend them freely. If something makes more sense and it doesn't follow in these guidelines, then do it. There's plenty of exceptions. There's always exceptions. No rule is set in stone. If you have especially critical code, I don't think that we will ever get rid of capybara tests on the happy path for a user creating an account, charging a credit card, finishing all their information, and starting a course, right? That is critical to code school. And if somebody can't do that, we're out of business. So it makes sense to test that and deal with the extra maintenance of a capybara test and something like that. It does not make sense to test and ensure that the word "you've completed all the courses" appears on your account page. We are not out of business if that word happens to not appear. You may be annoyed, but we can deal with that. We'll give you a discount. Code that breaks frequently, whatever the reason. Maybe it's a class that a lot of people touch. Go ahead and write a unit test for it. Go ahead and spend the time to make your unit test really fast. One of the main reasons I really don't like speed, though, as an argument for unit tests is that think to yourself, how long does it take for you to get bored when you're watching the dots? For me, it's about 6 to 10 seconds. And unless if you're willing to spend the time and invest all of the money that it requires to make your unit tests pass in 6 seconds for a Rails app, especially if you have to initialize Rails for your tests, which takes 3 or 4 seconds on a good machine on its own, you're wasting your time because you're going to go check Twitter and you're going to be back in 5 minutes anyway. Use Travis or set it off into another window and keep coding. HTTP APIs. You have to test those from the outside because the headers, the response headers, are an important part of the contract, right? Does it return 200? Does it return 503? Does it return 404? Whatever. That's a part of the contract. You have to test it. You always have to test the contract. And mindset is important. Part of the reason that I'm doing this, at least for myself, is to create the right mindset to create good code. So if I don't have any controller tests, I'm going to write really simple controllers because I'm not going to want to get tripped up on some stupid mistake in my controller. If I'm not testing my views, I'm going to have extremely simple views. If I have to write tests and documentation for my public methods, I'm going to make really damn sure that they need to be public, which is kind of an issue in the Ruby community where we tend to make everything public. Private is a good thing. You want to encapsulate your classes and make sure that people can't poke in and get into the messes they shouldn't be calling. No private method test means you're going to have good feature tests. If you run code coverage and you think you have good feature tests and a private method has zero coverage, then that method should not exist. Less time trying to understand code means you're going to be happier programmers. Less time trying to maintain tests, going to be a happier programmer. I mean, who here has had the experience of spending 2 hours working on a feature and 4 hours fixing the test for it? I see a lot of hands. It infuriates me. It ruins my day. I know it ruins a lot of other people's days too, and it shouldn't happen. And working the way that works for you means happier programmers. I think that we programmers, we're always looking for ways to get more productivity out of ourselves, but we're also are really good at forgetting that you need to be happy as a baseline to get any productivity out of yourself at all. And your team needs to be happy. Morale is important, right? And crushing people over their particular choice of tools is not a good way to get there. And that's it. If you would like to see the slides, they're at thomasmeeks.com/controversy. And questions, thoughts?